Hello, in this video, we will look at how to handle collisions using open addressing. A collision occurs when two keys are mapped to the same index in a hash table. Generally, there are two ways for handling collisions: open addressing and separate chaining. Open addressing is the process of finding an open location in the hash table in the event of a collision. Open addressing has three variations: linear probing, quadratic probing, and double hashing. Let's look at linear probing. Linear probing searches for the next available open location linearly. So, for example, these are our occupied locations. Now we have 26. 26 is mapped to 4. 26 remainder 11 is 4. So 4 is occupied. Next 5 is occupied. Next 6 is occupied. Now come to 7 is available. So this is linear probing. Let's look at the linear probing animation here. So we're going to now use 26, and we're going to put 26 at the location 7. So this is 26. Now search, 26 is there. So let's remove 4. When you remove 4, you need to put a special notation. This is the class marker here to denote that this position is available for insertion. But when you search it, you should check the next location. So let's search for 4. 4 is not in the hash set. And let's look at 26. Now 26 is in the hash set. The problem with linear probing is that you will soon have accumulated clusters. The clusters can be very large. To avoid to have large clusters, we're going to use double quadratic hashing. So linear probing is you always go to next. For the quadratic probing, so we're going to jump. We're going to jump quadratically. So here is k plus j squared for j starting from 0, 1, 2. So now your k plus j squared is k plus 1, k plus 2. So for k, j is 1, 2. And then for j is 3 is, this is k plus 9. For the same example here, we're using quadratic probing. So 26 is mapped to 4. The next one is, so that is j is 1, so j squared and is 1, so that's 5. And then we have this is, you're going to jump here, you're going to have this is the k plus, with this j is 2, so that's k plus 4. So k is 4 plus 4 is 8, so it's going to be put at this location 8. So here is the animation. Let's insert 26. 26 is put at this location. And let's do a search for 26. 26 is in. So let's do a delete of 4. So we're going to delete 4 now. Put a marker right here. And let's search for 4. 4 is not there. And let's search for 26. And 26 is in the hash set. Now with quadratic probing, we still have the invisible clusters because you have the fixed jump. So you always jump fixed. So plus 1 and plus 4 plus 9. And we are going to now change it in the double hashing. In the double hashing, we're going to have this secondary hashing. So how far you jump is determined on the key. So this is k plus j times k prime. So we have secondary hash function h prime. So h prime's key. So j times h prime key. Let's define this is h prime. H prime key is 7 minus key remainder 7. So let's use this now. So let's look at this 12 here. So here for 12 is mapped right here to 1. So it's occupied. So the next you are going to have h12 plus this is 1 times h prime 12. H prime 12 is this is so this one here is 5 and this is 7 minus 5 is 2. So h prime 12 is 2. So this is 2 right here. It's occupied. And then we come here to this 2 times h prime 12. That gives you 5 now. So this is the 1 plus this 4 is 5. So let's look at the animation here. So this is double hashing. So let's see, I'm going to use this key value is 11. So here is 11 is going to be mapped to this 0 right here. It's occupied. And then we're going to look at 11, remainder 7 is 4, and 7 minus 4 is 3. So this is going to be 0 plus 3. So now you're going to see 11 is put at the location 3. So 11 is here, and search for 11. 11 is in this hash set. And now let's remove 44. So we're going to remove 44. So put a marker right here. Let's do a search for 44. 44 is not in the hash set. Let's search for 11. 11 is in the hash set. That is all for this video on handling collision using open addressing. See you on the next video.